Hi y'all, today we are learning about the four kinds of factoring. So the first one is the greatest common factor. This is the first step on every problem, right? So you always want to try to take out something. That's always going to make your problem easier if you have something there. So I'm going to look for something that's in common between my two terms here. I can see that they're both divisible by 4 and that I can take out an x from each of them. So I know that 4x is going to go to the outside. And then I'm going to actually divide and see what's left. So 8 divided by 4 is 2, and x squared divided by x. This is like saying x times x. We can cancel these ones, and that's going to leave us with 1x left, right? And then 4x divided by 4x, anything divided by itself is 1. So I'm going to put a 1 there. So we could say that this is the exact same thing as this. It's just written in factored form. So this would be my factored version. So greatest common factor, we're just trying to take out something that both have in common. So I'll do all of the second examples in a separate video, but we're just trying to take out something in common. So the first step will always be to look for a GCF. So I'm looking in here. I don't see that these have any variables in common from all three, and there's no numbers, so I know that I cannot do a GCF. So I checked for a GCF. There was nothing there. I see that this has 3 terms that include an x squared, an x, and a constant term. This is called a trinomial, right? So you might hear that word sometimes, trinomial, which really just means you're going to use the x factor. So this is the number, the last number is what I need to multiply. So negative 72, multiply to get negative 72, add to get negative 1, right? So this number here, which is negative 1. So I need to think of two numbers that multiply to get 72, add to get 1. Let's see, I've got like 2 and 36. Those numbers are not going to add to get 31, or I'm sorry, add to get 1. Maybe 3 and something, but it's always going to be luckier to find numbers that are closer together because we have a negative 1 here. So I'm going to try 8 and 9. 8 and 9 will multiply to get 72, and then I need negative 1. So I'm going to do negative 9 and positive 8. So when I factor, I'm going to have x plus 8 and x minus 9. And I leave their factors here. I'm not going to switch the signs. I'm not going to write like x equals negative 8. I'm not going to do any of that because they're only asking me to factor right now. I'm not solving, just factoring. Right? So I'll do these ones in another example. So for difference of squares, the difference of squares is a theorem you probably might remember. Let's say you have x squared minus 16. So x squared minus 16 would be x plus 4, x minus 4. We take the square root of the first one and put the two pieces right here. X times x gives you x squared. And the square root of the second is 4 times 4. And then we have one positive sign and one negative sign. All right, so the first thing we always need to look for is a GCF. I look here and I see that they're both divisible by 2. So I'm going to go ahead and take that 2 to the outside. That leaves me with x squared minus 50 divided by 2, which is 25. Right? From here, I can see that x squared is a square and 25 is a square, and it's minus, so that makes this the difference of squares. So I still have the 2. I'm going to make 2 here. The square root of x squared is x and x. Square root of 25 is 5 and 5. I have one positive and one negative. So this would be my factored form or my original equation here. Again, I'm going to do the other examples on another video. Check it out. And then the last one is something that looks like this. This is the x factor when a does not equal 1. So again, we see the 3 terms, which is going to tell us that we're using the x factor. But this time, I'm going to first check for a GCF. GCF, there's nothing that they have in common. I see that these both have x's, but that one doesn't have an x. Maybe, and then really all of those, 2 and 11 are prime numbers, so it's not going to work out. So I know that there's nothing that I can take out. So what I'm going to do is I'm going to rely on the x factor and the box. So I know that in the box, this one here will always go in the corner. And then 15 will always go in the other corner. And I know that these two boxes need to add up to 11. So I know I'm going to be adding to 11. And then normally I would put 15 up top as C. But when you have an A involved, when you have 2 here, you need to multiply that times here when you're working in, with the X. So 2 times 15 will be 30, which is, I need to think of things that multiply to get 30 or add to get 11. I've got 1 and 30. I've got 2 and 15. I've got 3 and 10. 4 and nothing, 5 and 6, and then 6 and 5, that goes backwards again. So I can see that which ones would multiply to get, add to get 11 is 5 and 6. So 5 and 6. So I know that this is 5 x's and 6 x's. So then I'm going to use my GCF skills again. So I'm going to look in this section here and I'll say, what do those have in common? What those have in common is 2x. And then I am going to try to figure out what I can put here. So 2x times something gives me 2x squared, and that number is x. So 2x times x gives me 2x squared. I'm going to try to figure out what this is. So x times 5 gives me the 5x here. And then 2x times something gives me 6x. That number is 3, and 3 times 5 gives me 15. So I know that these are my correct, not sure what you would want to call them, factors. So you would have x plus 3 and 2x plus 5. With this method, you don't have to do any crazy like division or anything. You can just multiply using the box, which most of you guys are pretty happy with. Cool. So that's the quick version. If you want more details, check out the second video. Thanks.